Well, 3D laser scanning is basically what it sounds like. We have a high-speed laser scanner that is mounted on a tripod, and it sends out thousands and tens of thousands of pulses per second. So it basically gets a point return from every little tiny space of any item, whether it be this wall, whether it be the photocopy of this desk. I mean, the laser is going to reflect off it and return back and give an XY coordinate for that position. So at the end of the day, or the end of that scan, you'll have a 3D point cloud of XYZ positions that you can take a digital picture of and overlay that picture on the point cloud. So now you have basically virtual reality. And that virtual reality is exactly that. You can go inside, you can measure from any item to any item, any feature to any feature. Potentially you could make animated people that would walk around in there. You can really use it for any type of virtual reality scenario. I heard somebody ask me once if we could scan an existing footage with bolt hole patterns in it. And I think the reason is when you design fabricated steel for anything, the tolerances are like 1/8 of an inch or 1/16 of an inch. And so if they're designing fabricated steel to something existing in the ground, existing footage and so forth, to have a 3D replication of that very precisely, they know exactly what they're looking at and what they designed to. So for that it would be very useful. For as-built, any type of as-built, of complicated piping, electrical work, any type of plant facility, even earthwork, we use it for doing very precise volumes. So anything as-built in any current conditions, it's extremely powerful. The only limitation is the laser has to have direct line of sight to it, so anything that's shielded from the laser beam by another feature or by the terrain, we'd have to move the laser around or pick it up conventionally with regular survey instruments, GPS or conventional instruments. Well, I think it's a ton of applications for architecture. Anytime that an architect wants to tie to an existing structure, if there's any deformation of that structure, it seems to be one of the weak areas of surveying right now is getting accurate survey information of vertical points in the air. For example, obviously with reflectless total stations we can shoot it, but all we're doing is getting an XYZ position of, say, 1 point on a ledge of a window. With this scanner we're getting thousands and tens of thousands and maybe even millions of points of the entire building, and so an architect can look at any position on the building and see really where it is in relation to everything else. So if he was going to rip the facing of the building off and tie to it, he would know exactly what he's got out in the field. It's extremely powerful because, as you know, many buildings, they may have real precise plans of how they should have been built, but how they should have been built may not be exactly how they were built. So now we give them a real life scenario of what is actually existing in the field, and that's powerful for an architect. Well, I think it's what I just touched on with architecture. I mean, you have a historical building, there's obviously no plans for it. Somebody basically built a building from their mind. That person is no longer alive, or if they are, they'd have to be extremely old, but most, I would think 99.9% of the time, they're not alive. So you have a structure that's sitting there that is, over time it's maybe sagged or shifted a little bit, and you can use the 3D laser scanning to scan every really inch of the building, including inside and outside. If you have a cathedral ceiling inside, you could scan all the structure of the building, the beams, and so forth, and really recreate the structure in a virtual world, how it is that actually exists, and you could start disassembling it piece by piece. And there obviously might still be some guesswork because there'd be items that are covered up or may not be apparent to the scanner or to the naked eye that are inside or behind, the outer covering of the building or the inside walls. But really it gives you a tremendous head start. Then the architect or whoever's looking at the historical building, could really start making a leap of, well, what might be behind that wall? What would support this type of wall? And they at least have an educated guess at it. So I would think it'd be a very powerful tool. In fact, if a historical building had to be destroyed, had to be because something had to go in, like a bridge or something to benefit, the community as a whole, it'd be nice to scan a historical building and, make a virtual replica of it before it disappeared from the world completely. That way, people could someday maybe have a virtual tour of what that building looked like. You know, I really think scanning could be endless in those regards, because there's going to be a lot of historical structures, even where I come from. Some of the covered bridges. I mean, it'd be nice to have the covered bridges scanned, because then, you know, those can't stand forever. Most of the covered bridges you can't drive on anymore, so they're either going to have to just keep them there until they fall in, or repair them, or they're going to have to take them out and replace them with newer bridges. So things like that are going to disappear from our landscape. It'll be nice to have those, you know, in the archives somewhere, basically. Well, basically, you know, if you've ever watched an archaeological dig, basically the old-fashioned way to do it is grid everything off in little tiny squares, and then they say where they found this item was in this grid B4 or E8, and then they know where they recovered it from. But with 3D scanning, you could set this scanner up. You could scan the whole site one day, take some dirt off, scan it 4 hours later, so you could actually date your scans and show as you're pulling the dirt off where you're finding things, you know. That is extremely powerful. And for the scanner to do its job, it does not need to send a person out there onto the site. All it needs to do is have a visible, you know, line of sight to whatever it's scanning. So there would be no surveyor or archaeologist stepping on stuff, destroying stuff, you know, hurting evidence of what they found. I would think it would be a huge advantage to any archaeological crew to have a scanner. I mean, obviously you'd probably still need just conventional surveying equipment, but this would be a great asset. Well, I actually think laser scanning is where GPS was in the 80s. When I went to college in the late 80s, early 90s, we used to have these big, huge suitcases that took these big, huge car batteries, and we could only do GPS at 3 o'clock in the morning. And if you said GPS to someone, nobody but pilots and people that had boats, and even the boat people back then, captains and so forth, didn't really use GPS. But they were the only ones who knew what it was. And as you've seen, GPS has infiltrated every aspect of our life. Cell phones, I mean, everything has GPS. Everything is positioned now. I mean, my iPhone has it. Automobiles have it. Basically, we got precise positioning for everything. So I look at 3D laser scanning as the same thing. 20 years from now, you know, SurvTech will probably have later scanners, obviously, but we will be, instead of going out and doing a 2D map, and engineers and architects and even landowners have to look at it and say, they have to relate this in their mind, they'll be able to pull up a 3D model and actually walk through the site, walk through the building, walk underneath the trees, see the drip line of the trees. Everything will be in 3D. Well, it'll be a virtual reality. Engineers will actually be building stuff in 3D and seeing how it fits into the site. And instead of making assumptions, they'll have all the data just like they were building it in the field. So the engineer will actually be building it in a virtual world, and the construction company will be building it in a real world. Well, I think scanning is just another tool. SurvTech is obviously a very high-quality surveying and mapping firm, and I think, you know, people say, wow, you do 3D laser scanning now. Well, there's some sites that 3D laser scanning right now will not be an advantage to us. But I think as engineers and architects and construction companies get more used to working in the virtual realm, it may be 20 years from now, nobody will want anything but 3D work. If you try to give them a 2D map, they wouldn't even know how to read it. They want to see a virtual world that they can walk through. So with that said, I think, you know, with us acquiring a laser scanner and moving into that arena, we now have the ability to kind of grow with the industry, and SurvTech will be able to provide that service to all of our clients, and really, I think, you know, help our clients move in that direction as well, because they can't move in that direction until surveyors start giving them data that they can look at and understand in that world. So that's what I would pretty much close on. I think we're helping our clients as well as ourselves enter the 3D virtual reality realm.
And that is surveying today with tomorrow's technology.
It pretty much is. I think right now laser scanning is pretty much the latest, greatest, newest technology out there. Obviously GPS has been around, like I said, for 20 years. Robotics has been around for a while. And this is really the next big leap. And I think as you see broadband, hard drive storage and other things increase, as storage grows exponentially, the whole world may be mapped virtually in 3D. I mean, I look for companies to be mapping everything in 3D. You'll have the virtual realm for everything. It'll constantly change, but there'll be constantly people mapping it, just like we do today.